Hi everyone. So today we're going to work on factoring special quadratics. Now there are a whole slew of special factoring that we're going to look at, but we're only going to focus on quadratics, which means these guys are x squareds. So there are two that we're going to focus on today, and the first one is called perfect square trinomials. And the second one are called difference of squares. Now, both of these can be factored with the methods that we talked about yesterday, but they have shortcuts that we're going to talk about so that they can make your life a little bit easier, but you can still factor them by the methods we talked about the other day. All right, let's talk about perfect square trinomials. These are... Okay, they are in the form ax plus bx plus c, but a is a perfect square. Okay. And so is c. So let's do it that way. They're perfect squares. And b is 2 times the unsquaring of a and c. So it's kind of like a squared and c squared. So for example, 9x squared plus 12x plus 4. 9 and 4 are both perfect squares. Okay, so these are perfects. And 12 is 2 times 2 times, or 2 times 3 times 2. Which is the square root of 9 and the square root of 4. Okay, so that's how we can identify them. Now, to factor them, what we're going to end up doing, we can do it with the going the long way, but if we recognize these as perfect square trinomials, they are the same thing written twice. Or you can write it as 3x plus 2 quantity squared. Okay? Now it's plus because the 12 has the plus sign. All right, so let's take a look at these. All right, so is this a perfect square trinomial? So is 64 a perfect square? Yes. Is 1 a perfect square? Yes. Is 16 2 times their square roots? The answer is yes. Okay, so we can factor it using that idea of just square rooting the first term, square rooting the last, and keeping the sign of the bx term, quantity squared. Okay, let's try this one. Is this a perfect square trinomial? First term perfect square? Yep. Last term perfect square? Yep. Is the middle term 2 times their square roots? Yep. So we're going to go x plus 7, because that's the square root of 49, quantity squared. Okay. All right, pause the video and see if you can do the next two. All right, let's check you out here and see how you did. Okay, so I gave you some hard ones. You had to factor out a greatest common factor first. You didn't have to, it just makes life easier. If you didn't, your answer would be 2x minus 6. Sorry, 2x minus 6. Okay? And then here, 3x plus 2 quantity squared. In fact, that's the same one we did in our example. All right, so that is the perfect square trinomial ones. The next ones are called difference of squares. Okay? Now, the reason we can tell these two is that it's 2 terms. Both terms are perfect squares. And the middle term is a middle term the middle sign, let's do that, is the minus sign. Okay, so it looks like this. A squared minus b squared. So they're both perfect squares, and there's a minus sign in between. And it's going to factor to a minus b, a plus b. Now the reason, it's basically we're just going to unsquare both terms, and one has a minus and the other one has a plus. Okay, so again, we're always going to look for a greatest common factor first to help make our lives easier. And then we're just going to basically unsquare them. Okay, and again, you can factor it the other method, but b would be 0 in this case. All right, so let's take a look at this. Do we have a GCF? Nope. Are they both perfect squares? Yes. Is there a minus sign in between? Yes. Okay, so we're just going to go x minus 8, x plus 8. Okay, and when you multiply them back together, there's no middle term, it drops out. Okay, let's start here. 8 and 200 are not perfect squares, but we can take out a greatest common factor. I believe 4 is our GCF. No, wait, does 8 go into 200? 25, yes, it does go in. I was wrong. Okay, so 8's on the outside, both are perfect squares, so x minus 5, x plus 5. All right, so why don't you guys try the other two and see how we did? Okay, let's check it out. All right, so both are perfect squares. There's no greatest common factor, so 2x minus 3, 2x plus 3. Both are perfect squares. No greatest common factor. Just to unsquare them, one's plus, one's minus. All right, so let's try some more. Okay, perfect square trinomial or regular? Perfect square trinomial. Unsquare them. Again, keep the sign of your b term, quantity squared. That should be a perfect difference of squares. 12 and 75 aren't exactly perfect, but they are multiple. Oh, we can do a GCF. I think 3. Yep. Okay, now when we look at both are perfect squares, okay. All right, pause the video and check out the other two. All right, so here we'd have to take out a GCF of 2, and then it becomes a perfect square trinomial of t minus 7 quantity squared. Here we took out a greatest common factor of 4. Even though 4 and 16 are both perfect squares, we always want to look for that GCF first. We get x squared minus 4, it makes it x minus 2, x plus 2. All right, guys, that's it for today. It's a short video. Let me know if you have any questions, and I will talk to you again real soon.